begin with question number 1 of MA112 final exam paper 2018 semester 2. 1a. Use the rigorous definition of limits to prove that the limit as x approaches negative infinity of x over x plus 1 is equal to 1. Now the first thing we can see is that this is of the form limit as x approaches negative infinity of a function, and that is equal to whatever limit we get. When it is given this way, we can use the statement, given that we have epsilon that is greater than 0, we are going to need to find n which is less than 0, such that the absolute value of the function minus its limit will be less than epsilon if x is less than n. So the function that we had is x over x plus 1, so we can substitute that in, and we're going to get x plus 1. The limit is 1, so we can subtract 1 from this, and it's going to be less than epsilon. Now we need to do a bit of work right here. Let's see if we can combine this. So what I can do is I can multiply the negative 1 by x plus 1. So it's going to go x minus x plus 1 over x plus 1, which is going to be less than epsilon if x is less than n. So now let's try and simplify the numerator. So we have x, negative times x is negative x, negative times positive 1 is going to be negative 1 over x plus 1. Now simplifying the numerator, we get x minus x is going to cancel out to 0, so we're left with negative 1 over x plus 1. Let's take the absolute value of the numerator and the denominator. Now the absolute value of negative 1, that'll just give us positive 1 on the top. The absolute value of x plus 1, we'll just leave that as it is. Absolute value x plus 1. Now what we can do is we need to get the x out of the denominator. So what we can do is we can take the reciprocal of both the left hand side and the right hand side, and do remember that when you take the reciprocal, you also have to flip the inequality. So if we take a reciprocal, we're going to get x plus 1 absolute value on the top. The 1 that was on the top is going to go down, and so we're going to divide by 1, so we don't have to write that. We're also going to change the inequality from less than to greater than, as well as the epsilon, that's going to be reciprocated as well. So it's going to be 1 over epsilon. Now, we want to try and get rid of this absolute value here, because we want it to be like this, just an x on its own. So if we go back to the limit, notice how it says in the limit x approaches negative infinity. So we are going to imagine that this x inside the absolute value is going to approach negative infinity. So what that means is that x is pretty much always going to be negative. So whatever you're going to have inside the absolute value, it's always going to be negative. And then when you take the absolute value of that, let's say expression, that's always going to be positive. So what this means is we can take the absolute value out. All we have to do is we have to add a negative outside, and then we just have used the normal brackets, x plus 1. Now notice that the left hand side over here, this is always going to be positive, because if you have a negative x, then you're going to multiply it by a negative outside here, and that's always going to give us a positive, so that's okay. Now we can try to get rid of this negative over here. Now what we can do is we can divide by negative. And remember, what happens when we divide by negative? Well, the inequality is going to change. So it's going to be x plus 1 less than negative 1 over epsilon. Now we're almost finished. All we have to do now is try to get rid of the plus 1. So that's going to go to the right hand side and subtract. So now we have x is less than negative 1 over epsilon minus 1 if x is less than n. So now we know that n is going to be equal to minus 1 over epsilon minus 1. So that's our final answer.